Hello, Forecaster here, and in this video we are going to have a look at the Railcraft token signals. Now, before we start, I want to mention that I'm using a resource pack that changes how the signal aspects are displayed to be more colorblind friendly. So it adds these shapes you can see in front of me. We have green on the left, yellow in the middle, and red on the right. It also changes the red color to be more orange, which is easier to see with certain types of color blindness. Now, the video itself is going to be divided into three distinct parts past this intro. In the first part, we're going to have a look at the basics. We're going to compare the token signal to the block signal, and we're going to show how to connect them and how to use them, very basically. In the second part, we're going to have a look at what the token signals do in the background, how they actually work. And in the third part, we're going to have a look at some of the problems you can encounter while using them that you have to be on the lookout for. So let's get started. Here we have two regular block signals, and I'm going to use the signal surveyor to connect them as usual. And these are now monitoring this signal block I've established on this side of the track, which happens to be the west side, which is what the signals prefer when there are multiple tracks. They can only monitor one side. And if I place a locomotive on the track and get it going, we'll see that the signals behave as we would expect. The far signal, which is the direction the train is heading in, turns red, and the close signal turns yellow. I can also use a signal tuner to connect this block signal to a receiver, in this case a distance signal, which just displays the received aspect. And everything will be as we would expect so far. Now, next we have a pair of token signals, and we'll stop this train. Now, the token signals I will connect with a signal surveyor, just as you would expect, and both signals turn green. So far, everything is the same. Now I will use a signal tuner first to connect to this distance signal, just the same. But here's where the differences start. So if I get this train going, we can see that when the train enters the monitored area, which is currently the same as the signal block over here, both signals turned red. And that is, of course, because the token signals do not have any sense of direction, unlike the signal block, which know which direction the train is heading in. And that might seem weird, but this usage here is wrong. You're not supposed to use the token signals like this, because I would obviously use a signal block here. The purpose of the token signals are very different. So, next up, in this configuration over here, we have 4 token signals. And if I want to, I can pair them up like this. But this, of course, is also wrong, because I would use signal blocks here. But we will demonstrate this just to show that it works like we would expect. We have one monitored section of track over here, and one monitored section of track over here. And each side will turn red, both signals, when the train enters that area, like you would expect. Now, here we're going to encounter another difference. So instead of pairing the signals up like this, I can also link them together into a group. So now I have 4 signals, 4 token signals, forming one group. And if I now put the train down, get it going, we will see that when the train enters this area here, all 4 signals will turn red. So this track, this area here, is also considered occupied. if I had a setup that would stop incoming trains using holding tracks or similar. But we also have an unmonitored section of track here that is not covered. So when the train enters that section of the track, all the signals turn green. Now, let's say I wanted to monitor that track as well. If I had been using block signals, I would have to add more signals to cover that section as well. But what I can do here is I can simply get rid of these two signals. Now we have the area starts here and it ends here. So when the train enters this area, the signals are going to turn red. Then it's going to go around the loop and come back here. And when it exits, the signals will turn green. So rather than a track that is constantly monitored by the signals, if we place a cart on the track between the signals in a signal block, the train will be, or in this case, the locomotive will be detected and the signals will turn red. Now, currently both are red because the train is stationary. And if I remove it, they will turn back to green. The same is not true for the token signals. If I place a locomotive inside of the area, the signals will remain green. Token signals only respond when something passes them. So we can see them more as gates rather than a monitoring system. So when a train passes a token signal, it is handed a token, which is where the name comes from, obviously. As long as one or more tokens are handed out, the signals will remain red. When a train with a token passes a signal belonging to the same group it got the token from, it will hand the token back. When all tokens have been returned, the signals will turn green. And I can demonstrate this pretty easily by having a train enter the area. Signal will turn red. Then we can have another train enter the area. And the signals will stay red. So it's not a toggle. It's not like a latch. Now, if I let the first train exit the area, we'll see that the signals will remain red. And they will stay red until the last train leaves the area, of course. And then they will turn green, like so. So, in part 2, we're going to have a look at the inner workings of the token signals. And to help with that, I've created this setup here. So what I've done is I've used Open Computers to replicate the token signals in a slightly simplified way to demonstrate what they are actually doing or something similar. So in the setup, we have a green area, which represents the outside. And then we have this red area, which represents our monitored area. So this is the token area, and this is outside. And over here, we have a computer, which is running a program that I've written, a very small program. And what that does is it monitors these redstone inputs here, which are connected to these detector tracks, which are directional, as you can see. And when a train enters the token area, it is going to increment a counter in this computer. And while that counter is greater than 0, it's going to display a red aspect here. When the counter is 0, it is going to be green. So to demonstrate this by sending this locomotive into the token area, And we can see that the aspect turns red, and then when the train exits, it will turn green. And if we go have a look at this screen over here, we can see that it detected an entrance. It incremented the counter, so it became 1. And then when the train left, it decremented the counter and it became 0, and the aspect turned green again. Now, I can also send multiple trains into the area. I can also catch a train inside of the area. So if I turn off that holding track or locking track, as long as the locomotive or train is inside of the area, we're not going to get the exit signal, and the counter is going to remain 1. Now, if I send another train in, and I catch that there, we're now going to have a counter of 2. And then when a train leaves, it's going to go down to 1. But because it's still greater than 0, the signal is still red. And then as the final train leaves, it turns back to green. And this is basically how the Railcraft token signals work as well, except they are a little bit smarter than this. So what we're going to do now is we're going to disable the computer system, and we're going to replace it with actual token signals. So let's grab one from here, and then we're going to put them above the tracks like this. So I'm going to put one here, put one here, and then we're going to use a surveyor to connect them. And now we have a token area inside of here. As you would expect, we will put down a new locomotive, make our train. And now when we send this into the area, we'll have the same result, of course. The signals turn red. I'm going to hook this up to my display here as well. Actually, we can remove this. It's less confusing. So our signal is red, just like we had before. And if I let the train exit, they turn green. Now, where the actual token signals are a little smarter than my computer system here is, of course, that for one, it's a lot simpler. I just placed these 2 blocks and it all worked. I didn't have to program anything. We also have a smaller footprint because here I needed 2 blocks to cover both, to differentiate between entrances and exits. These do that automatically, of course, in a different way. Another thing that the token signals do that make them smarter is that they track this locomotive, this token that they've handed out. If it disappears through other means than passing a gate again, say I destroy this locomotive, you can see that the signals turned green again because the token no longer exists, which is all they really care about. So I can now send another locomotive into the area. And if we park that there, and I send another one, have that get caught in there, we now have a token count of 2. And if both of these are destroyed, if one of is destroyed, there's still 1 token out there, so the signals remain red. But if I destroy both of them, the signals turn green again. Pretty simple, nice and easy, hopefully. So now we come to part 3, where we are going to have a look at some problems you can have. So if I once again send a train into the token area, as we would expect, the signal is going to turn red. And then when it comes back out, turns green. However, if I flip this switch here, this switch lever, and I have the train exit the area through a track that does not have a token signal on it, which would be this side track here. Now we have a problem. As you can see, the signals are still red because the token area still has a token handed out, which is held by this train here. So now, if I flip the switch back, and I just have the train go in a loop, we can see that when the train passed the gate, the token signal, the token was handed back and the signals turned green. And then when it passes this gate, the signals turn red. So what I've essentially done is I've flipped the sides. So now this is the outside and this is our token area, which is not what I wanted, obviously. The other side was supposed to be the monitored zone, the token area, and this is the outside, but now I've changed them because I forgot to put a token signal on this track here, and I let a train escape without passing one of the gates. Now, to fix this, I can, while this is red, I can remove this locomotive, which would cause the signals to turn back to normal, to green, and then I can place it again, and I can get it going, and things are now back to normal. And obviously, to fix this problem, or prevent it from happening again, I would want to place a token signal here, and I would hook it up into the group. I'm not sure why this got unlinked, but whatever. Let's fix this quickly. So now you can see that we have 3 gates. All exits and entrances are monitored. So now if I flip the switch lever again, doesn't matter if the train exits through this track, it will still hand back its token, and the sides will not be flipped. And that's pretty much it, I think. Another thing to look out for, of course, which we should give a shot, is placing trains inside of the token area. So if I place one here, you can see that when it passes the gates, the signals turn red because they hand out a token to a train that didn't have one because it passed a gate. But it was already inside of the token area when it was created, so it was not given a token. So there are a couple of ways to solve this problem. One is to not create any new trains within the token area, of course. But maybe you want the ability to spawn trains in there with cart dispensers or train dispensers. Or you just want to be able to place them manually. And the 2 solutions I can think of off the top of my head is, one, to have another unmonitored side track like we had from the start. I'm not going to create a switch here, but we would have a switch here. And then we create our new trains on this side track here. And then we can send them off, and it will join the regular track and go about its business as normal. Now, this setup or this solution demands that we have a very particular setup where this track is allowed to exit to go outside the area. But what if we have a station with a little side track where new trains can spawn on this track, and then they are supposed to enter, say, a passenger terminal and pick up passengers or pick up goods or whatever. So in this case, I'm going to get a spike wall to fix this here. Here, we would simply put a token signal, say here, and join it to the group, like so. So now new trains that are spawned on this track will enter the token area and given a token when they leave that track, and the token area will behave as normal. So there we have it. There we have a walkthrough of the token signals, how to use them, what to look out for and such, and how they work briefly. I hope this has been educational as usual, and I will see you in the next video.